Hey folks, welcome back to another video. Today we'll be looking at question 2, add two numbers. So the question that we have today is given two linked lists where the numbers are actually reversed. What would be the order of that? So let's jump right in. Oh, sorry, spelling error. Okay. So there are a couple of things that need to be initialized right before we jump into the solution. We need a dummy node. Let's just call it the previous node. So new list node, and you'll understand why in a second. And then you'll have a list node called head that would just point to the previous node. And all the way after everything is done, you would just return head.next. And here we have the while loop. So while L1 is not equal to null, or L2 is not equal to null, or carry is not equal to null, is not equal to 0. So as long as one of these three conditions are not completely satisfied, you need to be doing the while loop, which means that, hey, like there are remaining nodes left in L1, or there are remaining nodes left in L2, or the carry that we have from the previous iteration is not 0. So let's just initialize that to 0. All right, so what do we do now? So we need to initialize a node called current that would keep a track of the sum itself, and then let's say in sum equals L1. So here we need to be careful, since if the length of these list nodes, the linked lists, are not exactly the same, you could run into an error. So you need to check if both of them are null or not. So if L1 is not equal to null, if it is not equal to null, then you would add L1.value, or you would add 0, and you would do the same for L2, and then you would do carry. Let's just copy this right here, and this turns to L2. Right. So we need to get the sum and the carry from this. So this would be current.value would equal to sum mod 10, and the carry would be equal to sum divided by 10. So that makes sense. We have the new values. There are a couple of things that you have to do. You have to point the last node, previous.next, is equal to current, and then the current node becomes the previous node, so that you can attach the next node to that, and so previous is equal to current. Yes, that makes sense. And also you need to move the linked list forward. So you would check, hey, if L1 is not equal to null, then L1 becomes L1.next, or it just stays L1. And you do the same for L2. Okay, let's quickly run this and see if everything is okay. Alright, the first example is good. All the other examples are good as well. Alright, so let's quickly go over the runtime and the space-time complexity. So the time complexity would be O of n, where n would be the number of nodes in the linked list, and space complexity would also be O of n, because we're initializing a new linked list that would store all of the sum. So if you have any questions about this problem, please let me know in the comments below. If there are any other questions that you want me to solve, also let me know in the comments below. And don't forget to like, share, and subscribe. I'll see you all in the next video. Peace.